Algebra sets. So intersections. You remember these. Intersection, when things intersect. Intersection means that X is an element of A and X is an element of B. If you have a union, that means X is an element of A or X is an element of B. Now, if you look at the pictures here, this is what I call the overlap of A and B. And we're only looking at the overlap, the part where X is element of A and X is element of B. We're not looking at these other ones. But the union is kind of the totality of A and B. And so we've got that overlap plus anything left over in B and anything left over in A. So if you look at this example, 1, 2, 3, 4, 5, 6, 3, 5, 7, 9, the intersection, of course, is 3, 5, 1, 2, 3, 4, 5, 6, 0, 7, 9. There is no intersection on that. Union, you just list all the members only once. So A, B, C, D, E, A, E, I, O, U. You're looking for the union of those, A, B, C, D, E, and then include I, O, and U. Even integers, odd integers, that's just going to be all the integers. Empty set in 1, 2, 3 is just 1, 2, 3, which is B. And the prime numbers and the natural numbers, the union is just all the natural numbers. So you get that. You've seen that. But it makes you think a little bit. We're putting some nomenclature to some of these. A intersect B as a subset of A union B. Could be total. Could be equal, but doesn't have to be. And then these you can look at. I think they're self-explanatory. And they show you an example of a proof that I also want you to read. So this is the only part that I need you to read. And then disjoint is no intersection. And I just wanted to show you that there's two ways to show it. Two circles not meeting, or a universe with a line in it where A and B don't cross. That's kind of cool. These mean the same. Complement is when you have a set, and then anything in the universe except that is your complement. So A intersect A prime, there's nothing intersecting the complement and the set, but the union of it is all, or is the entire universe. So if we go to these, I just set these up because I thought it'd be helpful to list the terms. I probably made this too easy for you, but after those proofs, got to make it a little interesting. A union B. So is that overlap or totality? A union B. What do you think? Totality or overlap? Totality. So go 1, 3, 5, and 7. And that's A. And then B is 0, 1, 2, 3, and 4. So those would be your union. B intersect C. What do you have there? B intersect C. What do you think? Yeah, not 0. The empty set is different than 0. In this case, 0 is a member. Empty set is the absence of members. A little different. E, A intersect B. So I'm going to use yellow for A intersect B. So A intersect B is going to be 1 and 3. And then A intersect C. It's all the values less than or equal to 9. Okay. That's everything, right? And then what's the union of those two? What's the union of those two? You did A intersect B, those are the two yellows, and then the intersection are the blues. The union of those are just going to be everything, 1 through 9. And you can write it 1, 2, 8, 9. You can do that. All right, complement means all of those that are not in A union B. So you do A union B and then do the complement. I think you can handle those. Then you're going to do some drawings and some Venn diagrams. There is a proof. 6 is a proof, and 5 are proofs. So those two, we'll go over those tomorrow.